Hello again, this is Sarpal Physics here again, and basically I was asked to look at this particular question here today, where we have an object basically that is projected at an angle of 20 degrees and is moving at a speed of 3 meters per second. So obviously if you got a direction and you got a speed, we're talking about a velocity instead. Now we're going to basically focus on looking at, say, this question here first of all. What we're going to do, we're going to first of all look at in what direction is this object going to be travelling. So we can see from here that the actual journey the object takes is actually going to be a parabolic motion, where the object basically lands on the surface again at this particular surface here, which runs along all the way across this surface here right now. Now, the thing to remember here is that we've got some we have got some letters basically that we can actually assign to this, and we say that the displacement, i.e. the distance travelled by looking at a straight line travelling from the starting point to the end point, is actually going to be shown by this here displacement. And we're going to say that the displacement acting in the vertical direction, i.e. upwards like this, in a vertical downward motion, we can say that yes, it does travel to a maximum height, okay, which we can say is going to be your H max, as I've written down here right now. However, as the object goes up to a maximum height, you can see that it will actually recede back down again, and it will actually go back to zero again. So it's going up and it's going back down, it's going up and it's going back down again. So we can say that the displacement, the symbol for displacement we normally use, is actually going to be S. And we're going to say that's going to be naught, and the units we're going to say is going to be meters, simply because the speed here is also in meters per second. Now, if you now know that basically displacement is equal to 0, we can now apply the equation. Now this equation is equal to S equals to ut plus your half a t squared. And again, we're going to be looking at the vertical motion again. And basically, it's going to be quite straightforward really. All we need to do really is by looking at the S. Now the S value is going to be equal to 0. The U value is actually going to be the vertical component, which is uy, and the way you work this out is we look at the angle at which basically the object is actually going to be projected at is 20 degrees, and we can say that the vertical motion here and the horizontal motion here are going to be can be calculated using trigonometry. And we can say that obviously this one here, because it's going to be, this can be seen if you be using trigonometry, we say it's going to be 3 sine 20 degrees. And similarly this one here is going to be 3 cosine 20 degrees as well. So now we can now look at this and we can say 0 is equal to uy. Now uy, remember, is going to be this one here, where uy is actually going to be equal to initial velocity in the y direction, and we can say that uy is going to be your 3 sine 20 degrees. Now this is actually going to be multiplied by a value time t. Okay, and then what we're going to say now is this is the time taken for the object to basically go up, all the way up, and reach a maximum displacement, and go back down again to 0 displacement, and the value for t is going to be here. Now we've also got this component here of the equation that we're using, half times acceleration times t squared. Now because it's an object that is actually moving against gravity, we can say the acceleration is actually going to be minus g, simply because it's actually moving upwards against the force of gravity. And we can say that it's going to be plus half minus g, and again we can have your t squared value here. Now by looking at this, we can now look at the equation here is going to be 0 equals to 3 sine 20 degrees. Okay, put a dot there. Times that by multiply by time. That's going to be a minus half. Now your g value, we can say it's 9.81 multiplied by t squared. Now by doing that, we've actually got a quadratic equation here now. By looking at, we can actually solve this quadratic equation simply by, if you were to calculate the 3 sine 20, and obviously calculate the half times by 9.81, then we'll have a number, obviously multiplied by t, minus your half times by your 9.81 t squared, and that's equal to 0. The rest of it, I would like you to have a go at, basically see if you can actually calculate the value for t. Now notice there's going to be two values for t. Obviously it's actually a quadratic equation where we have t equals to the value assigned here, and at the same time we're also going to have a t value which is going to be obviously assigned at this particular time here as well. So that's all for now from Sarpal Physics again. This is looking at basically projectile motion for A-level physics. Please do subscribe to my channel if you've got a bit of time. Okay, I hope you do anyway. And basically I look forward to hearing from you really soon using your comments. I'll be able to also add more clips on, basically depending on what you want to know. That's great, brilliant. So see you soon, bye.